In this video, we are going to solve one question concerning inverse and equality of matrix. Here is a question. If matrix A equal to this 3 by 3 matrix and A inverse equal to this 3 by 3 matrix, what are the values of x, y, and z? To solve this question, we can find A inverse from the given matrix A and then equate the elements of the matrix we found with the corresponding elements of the inverse matrix which is given. Or we can find matrix A from the given A inverse and then equate elements of the resulted matrix with the corresponding elements of the given matrix A. As we can see here, all the variables which we are asked to solve for are in matrix A. So, finding A inverse from matrix A or converting matrix A to A inverse will be somewhat complicated. The simple path is to find matrix A from the given A inverse because there is no variable in A inverse. Let's use this general formula to derive matrix A from the given A inverse. A inverse times identity matrix equal to identity matrix times matrix A. As it is stated in the formula, what we are going to do is to carry out elementary row operations that help us to switch A inverse and identity matrix. To do so, let's form an augmented matrix and set elements of A inverse to the left of the vertical line and the 3 by 3 identity matrix to the right of the line. Our next task is to switch these two matrices. Let's move from column by column, starting from column 1. To change this 2 to 1, we have to multiply row 1 by the reciprocal of 2, that's 1 over 2. These two elements of column 1 are the same, so we can derive similar formula in order to convert them to 0. If we multiply negative 1 by 2, it gives us negative 2, which is the opposite of these two. The sum of equal and opposite numbers is always equal to 0. So to change this negative 1 to 0, we can use the formula 2 times row 2 plus row 1. By the same analogy, the formula 2 times row 3 plus row 1 can be used to convert this third row negative 1 to 0. Multiplying row 1 elements by 1 over 2 gives us 1, 1, 1 over 2, 1 over 2, 0 and 0. Let's calculate 2 times row 2 plus row 1. Of course, that product goes to row 2. 2 times negative 1 equal to negative 2. Negative 2 plus 2 gives us 0. 2 times negative 3 over 2 equal to negative 3. Negative 3 plus 2 gives us negative 1. 2 times negative 1 is negative 2. Negative 2 plus 1 equal to negative 1. 2 times 0 is 0. 0 plus 1 gives us 1. 2 times 1 is 2. 2 plus 0 is 2. 2 times 0 is 0. 0 plus 0 equal to 0. In casting forward to row 3, 2 times negative 1 is negative 2. Negative 2 plus 2 is 0. 2 times negative 1 is again negative 2. Negative 2 plus 2 equal to 0. 2 times negative 1 is also negative 2. Negative 2 plus 1 gives us negative 1. 2 times 0 is 0. 0 plus 1 equal to 1. 2 times 0 is again 0. 0 plus 0 is 0. 2 times 1 is 2. 2 plus 0 equal to 2. Next, we have to change this column 2 elements to the form similar to column 2 elements of the identity matrix. To change this one to 0, we can add it with negative 1, which is already here under 1. So the formula row 2 plus row 1 can be used to make this one 0. To change this negative 1 to positive 1, we have to multiply row 2 by negative. The third element is what we needed, so no operation is needed in row 3. Let's add row 1 and row 2 elements to determine row 1 entries. 0 plus 1 equal to 1. Negative 1 plus 1 gives us 0. Negative 1 plus 1 over 2 gives us negative 1 over 2. 1 plus 1 over 2 equal to 3 over 2. 2 plus 0 equal to 2. 0 plus 0 equal to 0. Multiplying row 2 elements by negative gives us 0, 1, 1, negative 1, negative 2, and 0. We don't have any operation in row 3, so let's copy them as they are. At last, we have to change this column 3 elements to the form similar to column 3 elements of the identity matrix. To change this negative 1 over 2 to 0, we have to add it with positive 1 over 2. If we multiply this negative 1 by negative 1 over 2, it gives us positive 1 over 2. Hence, negative 1 over 2 times row 3 plus row 1 is the formula that can convert this negative 1 over 2 to 0. These two elements are equal in magnitude but opposite in sign. Thus, adding them gives us 0. So to convert this 1 to 0, we have to use the formula row 2 plus row 3. Multiplying row 3 by negative changes this negative 1 to positive 1. Let's move to the operations. Negative 1 over 2 times 0 is 0. 0 plus 1 equal to 1. Negative 1 over 2 times 0 is again 0. 0 plus 0 gives us 0. Negative 1 over 2 times negative 1 gives us positive 1 over 2. Positive 1 over 2 plus negative 1 over 2 equal to 0. Negative 1 over 2 times 1 is negative 1 over 2. Negative 1 over 2 plus 3 over 2 is 2 over 2, which is equal to 1. Negative 1 over 2 times 0 is 0. 0 plus 2 is 2. Negative 1 over 2 times 2 is negative 1. Negative 1 plus 0 is negative 1. The sum of row 2 and row 3 elements gives us 0 plus 0 equal to 0. 0 plus 1 is 1. 1 plus negative 1 gives us 0. Negative 1 plus 1 again 0. Negative 2 plus 0 is negative 2. 0 plus 2 equal to 2. Multiplying row 3 elements by negative gives us 0, 0, 1, negative 1, 0, and negative 2. Now, the matrix to the left of the vertical line is identity matrix. Therefore, the matrix to the right of the line is matrix A. This matrix is the matrix given in the question. If we compare the element of these two matrices, except those expressed by using variables, all other elements are the same. These two matrices are equal only when the corresponding elements are equal, meaning x squared minus 2, which is in row 1, column 2, that it has to be equal to row 1, column 2 of the resultant matrix. That's x squared minus 2 equal to 2. Taking negative 2 to the right of equality sign gives us x squared equal to 2 plus 2, which is 4. If we take the square root of both sides of the equality, we get x equal to plus or minus 2. Y plus 3 is in row 2, column 2, and it has to be equal to row 2, column 2 of the resultant matrix. That's y plus 3 equal to negative 2. This implies y equal to negative 2. Taking plus 3 to the right of equality sign becomes minus 3. This implies y equal to negative 2 minus 3 gives us negative 5. 2z minus 3 is in row 3, column 1, and that has to be equal to row 3, column 1 of the resultant matrix. 2z minus 3 equal to negative 1. This implies 2z equal to negative 1. Taking minus 3 to the right of equality sign becomes plus 3. This implies 2z equal to negative 1 plus 3 gives us positive 2. Dividing both sides of the equality by the coefficient of z gives us z equal to 1. This brings the end of part 21. Have enjoyable time.